ladies and gentlemen. Welcome to lesson 5.2. We're going to be proving that triangles are congruent by using SSS and SAS. SSS stands for side, side, side. And so what we're going to prove is that if two triangles have the exact same side measurements, all three sides match up, then they're congruent triangles. They're the exact same shape and size. And if we can have a side, an angle, and a side that are the same on two triangles, then those two triangles are also going to be congruent. So that's what our goal is, just to show that those are congruent. All right, so let's take a look at our first vocabulary. We're going to introduce you to proofs today. And what a proof is a convincing but mathematically accurate argument that shows why something is true. Two-column proofs are a way to show a logical argument. And so what we're going to do is you're going to try and convince someone that two things are congruent, two things are equal to each other. But you have to use logical statements, and they have to be mathematically correct. And so what we're going to do is we're going to learn how to go through that flow of the logic, what we need to start with, and where we're going to finish at, and what those statements in between need to look like. And so we'll take a look at these two-column proofs. All right, so our first thing is postulate 12, the side, side, side congruence postulate. And what that says is that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So let's take a look at what they mean by that, where the side, side, side comes from. So if side, MN, is congruent to QR, we can see that they're congruent by the congruency marks. And NP is congruent to RS. We can see it by the congruency marks. And, so this and means we have to include all of them. PM is congruent to SQ. Then we can say that the two triangles are congruent. We've got to go back to what we did on lesson 5.1 about naming congruent parts with congruent triangles with corresponding parts. So if we look at M is the angle that's formed by my red and my blue, my 1 mark and my 3 mark. So I need to go over to my second triangle and I need to look which angle was formed by red and blue. Well, that's angle Q. So if M is listed first in this first triangle, Q has to be listed first in the second triangle. We then go to N. N was formed by the red and the green, the 1 and the 2. We look over here, R is formed by red and green, the 1 and the 2. So R is the next angle, and then that leaves S. So that's what our congruency statement looks like because we chose the corresponding angles in that order. So that's what we're looking for. Three sides that are marked as congruent in each triangle, matching up, and then we can say that the two triangles are congruent. So let's take a look at example 1. Does the diagram give enough information to use the side, side, side congruency postulate? Explain. So from our diagram, we can tell that HJ is congruent to LJ. Okay, we can tell by each of them have one congruency mark. And we can tell HK is congruent to LK. Name corresponding parts. J is at the end of each segment, so J is at the end of the segment. K is at the end of the HK segment, so K is going to be at the end of the LK segment. And then by the reflexive property, we know that JK is congruent to JK. This third side is the same in both triangles. But we know that it's congruent to itself because of that reflexive property, which is why it is so important for us to learn those in chapter 2. Because all three pairs of corresponding sides are congruent, we can use the side, 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 SSS congruence postulate. So we're going to conclude that triangle HJK, we need to go in order. H corresponds to L. That's where green and red come together. So L will be the first angle. J is where the 2, 1 congruency mark sides come together, so it's going to match up with J. When we go around from that, we went from H to J, we have to go from L to J. Sorry, guys. And then we went from H to J to K, we have to go from L to J to K, so we end at K. When they share that side, we'll often see that two of our angles are written in the same order. So we kind of follow the path. We went from H to J and J to K to name our triangle. We're going to go from L to J and J to K to name our triangle. All right, so that's what SSS looks like. Now we're going to take a look at what side angle side looks like, the side angle side congruence postulate. So the two sides and the included angle. What this also means is the created angle. It's the angle that two sides create of one triangle are congruent to two sides, and the included angle of a second triangle, then the two triangles are congruent. And that's why it's called side angle side. You have to move your pencil as you trace things with your pen or your pencil. You have to hit a congruent side, then a congruent angle, and then another congruent side. You have to go in that order. So here's what side angle side is going to look like symbolically. If PQ is congruent to WX, and I know that because they each have one congruency symbol, and Q is congruent to X, angle Q is congruent to angle X because they both have one congruency symbol. So I went from side to angle, and then QR is congruent to XY because they both have two congruency symbols. So I'm able to follow the path of side, congruent angle, congruent side, congruent side, congruent angle, congruent side. I hit all my congruent marks, my congruent corresponding parts with one smooth movement of my pen. I know that I've just used side angle side. So when we start to name things, we go from P to Q to R. P corresponds to W. Q corresponds to X. And R corresponds to Y. So triangle PQR is congruent to triangle WXY. Now we want to use side angle side congruent statement. We want to see, can we use that? So we want to do the diagrams, give enough information to use side angle side congruence postulate. Explain your reasoning. So if we look at what we know, I know AB is congruent to CB. I know that they're congruent because they each have one congruency mark. And I know that DB, if we look at DB, has to be congruent to DB. They share that side, that's that reflexive property. The included angle between AB and BD is this angle right here, is angle ABD. The included angle between CB and DB is this angle right here, which is going to be angle CBD. And because the included angles are congruent, they're both 90 degrees, they're both marked as being 90 degrees, I can use the side angle side congruence postulate. The two sides meet at a congruent angle. These two sides meet at the same corresponding congruent angle, so that's what side angle side is. So triangle A, B, D, we go in that order, is congruent to, I need to start at C, because C corresponds to A, then B, then up to D. If we take a look at what we have here, I know that GF is congruent to GH. I can see that. And I know that GE is congruent to GE because they're reflexive. But the congruent angle, the angles that are congruent here, angle GEH, so if we follow angle GEH, and angle GEF included. If we look at this, I can follow my two sides, and there's no angle in between them. I can follow my two sides, and there's no angle in between them. The angle is away from them. If you take your pens and where my reds meet, there's no marked congruent angle there. So because it's not included, I cannot use the side angle side congruence postulate. Okay, so we see the included angle is where those two sides meet. Non-included angle is away from where our two marked congruent sides will meet up. All right, so in example 2, what two angles must be congruent in order to use the SAS congruency postulate? So we want to go back and take a look at what ones need to be marked there. So we will do in class for that one. Okay?
All right, so here we go. We're going to do that together in class.
The checkpoint, I am going to do one with you, and then I'd like you to do 2 on your own, and then we'll do 3 together in class. So number 1, does the diagram give enough information to determine that the triangles are congruent? So I've got corresponding congruent side, and so actually I'm going to mark that with red. So not just circle it, but I'm going to mark that with red. Mark that with red. I've got a corresponding congruent side. I'm going to mark in green, and I'm going to mark in green. And then I look here, and I've got congruent angles. So I've got 2 sides and an angle. Is that angle in between the sides? So if I look, my blue is where the red and the green meet. My blue is where the red and the green meet. So I can go from side to the angle to the side. So my answer is yes, because I have side, angle, side. The angle is included. I want you guys to do number 2 on your own. And this will be a check in class. Alright, so as I said, you're going to do number 2 on your own. And then you're going to, well, number 3 we'll check in class just to make sure and do that one together. Actually, I shouldn't say check in class. We will do in class. I want to have number 3 together. So on your own for number 2, we need an answer. Number 3 is they do together in class. Alright, so now we're going to take a look at our steps for writing a proof. The first thing we're going to do is we're going to list the given information. They're going to give you information. Isn't that nice of them? So we're going to list that given information first. Then what we're going to do is decide whether I can use the given information as it is, or if I need to make extra statements based on that. So I may know that something is right angles, but then I need to say that those right angles are congruent, because all right angles are congruent. So just because they tell me I have 90-degree angles doesn't mean that I know that they're congruent. So there's sometimes those extra steps you have to list, that extra logic. You list your statements in sequential order. In other words, you don't list a conclusion before you list the statement that allows you to make that conclusion. So for instance, I'm going to say that Jesse didn't have his homework done. Well, how would I know that Jesse didn't have his homework done? Well, I needed to tell you Jesse was absent. So now I can tell you Jesse doesn't have his homework done. I know that that follows exactly that logic. Otherwise, I'm just making a really mean conclusion about Jesse, which could be proven false. But if I tell you Jesse was absent on Tuesday, on Wednesday Jesse doesn't have his homework done, that's the logic of the order that we have. What we need to do then is give a reason for every statement we make. And so sometimes what would be our reason has to start off with some sort of statement, and then we conclude it, we justify that. As reasons and proofs, we use given information, so you're going to see the word given. We use labeled diagrams, so we mentioned that they are perpendicular or that they're parallel. We use postulates, we use definitions, and we use theorems. So you're going to see that reflexive property. We use our properties as reasonings also. And then we end the proof with the statement that we are trying to prove. So we end our proof saying that these two triangles are congruent. And that's often going to be what our proofs are about in this chapter. Alright, so we need to write a two-column proof that shows that triangle HJK is congruent to triangle LKJ. If you look at this, I can see I've got one congruency mark, so there's one side. Here's two sides, and hopefully you're catching on that the shared side is also going to be congruent. So I can see that they're congruent. I've got side, side, side. What you have to do is you have to go through and you have to explain that to me. So the first thing that you're going to tell me is that HJ is congruent to, you have to tell me which side it's congruent to. So we're matching those up, and we're going to say LK. And how do you know that? Well, it was given to you in the diagram. No one told you that. You didn't have to do any math. You didn't have to do any logic. Those marks were given to you. So that's what a given statement looks like. We then say HK is congruent to, we need to say LJ. And we know to list L first because H is first here and L is first in the triangle we're trying to prove. So that tells me they're telling us that H and L are the corresponding angles there. How do I know that HK is congruent to LJ? They're marked as being congruent. That's given. Well, then we just went through and we did this on our own. We said that JK is congruent to JK, and the reason being the reflexive property of congruency. A lot of your proofs are going to look like this, guys. They're kind of a fill in the blank. So when I saw reflexive property, I know that means something is congruent to itself. So I was looking for which side is shared between there. So now I've just marked three sides congruent. That's enough for the side, side, side congruence postulate. So that's what it looks like to prove things congruent. All right. We'll take a look at proving triangles are congruent. So in the diagram, we know PR is congruent to, or is perpendicular to AG, and that RA is congruent to RG. Write a proof that shows that. So the first thing we need to do is label the diagram. So when they tell me that DR is perpendicular to AG, I find DR, I find AG, and perpendicular means they make two 90-degree angles. So I'm going to put those 90-degree angles in there. They then tell me that RA is congruent to RG, so RA is congruent to RG. I'm going to put in those congruency marks. Now you're going to write what you're given and what you need to prove. So I'm given that DR is perpendicular to AG. And I'm given that RA is congruent to RG. What this means is that these two statements, even though I drew them into my diagram, I have to make them written in my two-column proof. And then what I'm trying to prove is triangle DRA is congruent to triangle DRG. I know that this is now going to be my last statement. So what we're going to do is write the two-column proof and list the given statements first. Alright, so what we want to do is we want to be able to list the two-column proof, or write that two-column proof, but we're always going to start by writing our given statements first. So if we look at what we have here, we know that RA is congruent to RG. How do we know that? That's given. It's given in our statements right here. So this given statement shows up right here. So the reason I know that, how did I know that? It's because it was given. I didn't have any special property, I didn't have any special definitions. It just showed up in the given information. DR is perpendicular to AG. How do I know that? Because it was given to me right here. So once again, that's what that given looks like. So then, we start taking a look at this, and it's, what do I know? Well, I know that DRG, so DRG and DRA are right angles because perpendicular lines form right angles. So that's what I know. They form right angles. That was something I had to conclude. I had to add that in there. But I concluded it from the fact that I had perpendicular lines. So then I'm going to say that angle DRG is congruent to DRA. So these two angles that I just listed as being right angles, I'm then going to list them as congruent angles. Because remember, I have to be able to prove that I have congruent parts. Not just that they're the same right angles, but that they're congruent. So we have to make that statement. The reason I know that is because all right angles are congruent. So then number 5, if we take a look at it, we have our reflexive property of congruence. Well, what would I be looking to use the reflexive property of congruence? Those are the shared sides. Anything that's shared is reflexive. So if we look, they shared this side. So I can say dr is congruent to dr. So now what we look at, we had a congruent side, we had a congruent angle, we had a congruent side. So I'm going to use my side angle side congruence, and I can't fit it all in the box, but hopefully you can. Congruence postulate, and now I need to write that I have congruent triangles. Remember, my final statement is what I'm trying to prove. So triangle DRA is congruent to triangle DRG because I've had side, angle, side. I had side, angle, side, side, angle, side. All right. So, ladies and gentlemen, if we take a look through here. Sorry, guys, I'm switching boards on you. This is our checkpoint. We will do this in class tomorrow.